Hello there, and welcome back to another day where I have some free time. And in this day's video of unstandard C, we'll be now adding the implementations of the syscall functions. So let us get started. Now we can have the source folder for syscall, and we can just call it syscalls.c. Wait a minute, that should be .c. So we can include syscall h over here. And from this, we can copy the functions we've declared, paste them over here, and add a few things for now. So first of all, the return value, actually returning something. The inline assembly for actually calling the syscall will be next. Oops. So number 3, um, oops, I messed that one up. 4, 5, and 6. Now for the actual inline assembly over here, I guess we'll be following GCC's inline assembly since we're using GCC to compile this. So the extended assembly, the one that you've been using in our C runtime, is this. So we'll be copying that. So I just want to use syscall over here. So ASM volatile syscall. Though I kind of want a way to automatically infer the registers. So I believe that is in, well, that should be in constraints, but oh, there's more. So constraints for particular machines. Since, well, we can just use R for a general purpose register, but what we want is the ones in the x86 family. So we want this to be RAX or the return register. And well, technically RAX is the A register, so call that A. And it will put the value of RAX to return. Then for our syscall number, we will be putting that in the RAX register as well. So A and then number. And the registers that we clobber, but we do not need to add RAX over here since, well, it's automatically inferred by this. So what we need to add are the registers that will be clobbered by syscall, which is, I think it was RCX, R11, I think, and memory. So there's that. Now for syscall 1, we need to add the argument. And the first argument here for the syscall will go to the RTI register. So it's letter D over here on the DI register. So capital D on A. Now for syscall 2, um, it will be in RSI. So it's capital S then for the B value. Then for syscall 3, the third one would be on RDX, I think. Yes, it is on this one. So that will be the D register. And then syscall number 4. So for the fourth value or argument, it is put in R10. And I do not know which one of that is in here. So, hmm, let's see if it has R10. Oh, but it's in another processor type or machine type. That's not what I want. Should be in the x86 family. So that is concerning to me. Maybe, maybe I'm not just reading this properly. So integer constants, then the stack, the call clubber registers, hmm, the A and D registers. Hmm. Let's just add it directly then on the general purpose register. So we'll just move that directly from um what number is this? 0, 1, 2, 3, 4, and 5 to R10. So let's just do that. Then for syscall number 5, we'll be adding another one. It's E this time. And then it's gonna go on R8. So move 6 into R8. No, I'm hoping that there's a better way to do this. I gotta search it up later on. So lastly, F, that will go on R9. And this should be the 7th value. So I guess that's it for the syscalls. Now we actually have to try it out. At first, we gotta modify Nobita to actually have libc. So let's add a shared library over here called lc, then add it via build. So build, add shared lib, call that c. Then the build tool, compile flags and sources. So gotta change that from CRT to LC. And the sources will be from syscall. So syscall slash syscalls.c. And then we can add headers. So target add headers lc Well, it's in the include directory relative to this executable file later on. And then syscall.h ended with null. Now the C runtime will have to depend on libc being built. So add dependencies, crt on libc. And then we actually do have to add a link flag to this maybe. No, this is still just an object file, so no need for link flags. It's here that we need it. So a formatted argument and just the normal link flag. So hello and add lc. So it would link to C. And over here, we will add a ways to, well, an argument to the linker for GCC that would make the executable automatically find our own libc version. So it's our path. So let us try this out. And I see that hello over here. Well, let's see if it links to our own hello. So Nobita build bin hello. Well, on our own libc, I mean. So it does. Let's try running it and see what would happen. It exited with 1, now 2. Okay. Now, instead of, well, let's try calling something else. So what can I do over here? Maybe have a status variable over here. And instead of adding move and syscall, we can just make it go to status, well, the exit status of main. Then we can do a syscall for exit, which is 60, I think, with exit status of, well, status. And then, well, before it exits, let us try to print hello world with a syscall. So what is syswrite over here? It's 1. And the file descriptor for standard output is 1 as well. Let's try printing hello world with a new line. And this is 14 bytes. So let's hope this works. Also, we need to trigger a recompilation for hello. And there you go. Hello world is printed by our syscall, but the status is wrong, surprisingly. So, hmm, I guess I messed this up. So let's try running it in GDB then. So break at start, then run it, step. So it's now making argc be 0. Well, let's try printing out argv then. Uh-oh, it's null. So it's now shifted again. So I guess we're at the mercy of the compiler suddenly messing with the stack. So quit anyway. And let's see an object dump of this. Over here at start, it subtracted, what is this, 16? So I guess it subtracts something from the stack when call is used. So, hmm, I guess we can do something about that. So let's move this by another byte. But we'll be removing these syscalls on start anyways later on. So we'll be dealing with that later on. But for now, um, well, it's still not right. So break at main, run it, and it's still 0. So that is surprising. But I just said that it subtracted 16 from the stack, so I'm not listening to myself. So quit that, rewrite this, build. There you go. It's now exiting properly with 3. So I guess we've done that properly now. We now have a generic syscall function. And for our next goal is to actually, well, implement the few syscall functions with the correct name. So implement the syscalls as C functions. So we'll be creating the unistd header file. So thank you for sticking with me this far, and may I see you on the next one.